So, I teach you according to Manipal. So, in the very first topic, they have told you the source transformation, right? What is source transformation? Basically, source transformation means we can convert. Basically, as you know, we'll have two types of sources, right? One is the current source and another one is the voltage source, correct? Current source is denoted by the arrow and voltage source is denoted by a battery symbol like this, or in some of the book they have represented like this, positive, negative. So source transformation means that we can convert from current source to the voltage source, or we can convert voltage source to the current source. Okay. Now you should know that how we can convert it easily. Like suppose if there is a current source and it is connected in parallel with the resistance. Okay. So there is must condition. If current source is connected with the parallel with the resistance, then only in that case we can convert it into voltage source. If suppose current source is in series with the resistance, then in that case we won't be able to convert it into the voltage source. Got this point? First point. Now suppose this is 10 ampere and 5 ohm and we need to convert it into the voltage source. The resistance which is connected in parallel, the same resistance would be connected in series with the voltage source. Here the resistance is 5 ohm, so here we'll connect 5 ohm. Now we need to calculate voltage, right? Because we want to convert from current to voltage. So it would be according to Ohm's law, V is equal to I into R. I is how much over here? That is 10 ampere and resistance is how much? 5. So the voltage is how much? 50 volt. Okay. Voltage we got it as how much? 50 volt. So this is how we can convert current to voltage source. Clear? Now next is how can we convert from voltage to current source. Again, there is a fixed condition that with the voltage source resistance must be connected in series, right? If suppose voltage source is connected with a parallel resistance, then in that case we won't be able to convert it into the current source. Clear? So now in this case I am taking the same value. Suppose it is 50 volt and that is 5 ohm, and we need to convert it into the current source. So as you can see, according to this, current is moving upward according to the sign convention of the battery, right? So in this case also current is moving upward, and the resistance which is connected in series, the same resistance would be connected in parallel, right? Here the resistance is how much? 5 ohm. So here the resistance is 5 ohm only, and here we need to get I is equal to V by R. V is how much over here? 50. Resistance is 5, so it would be how much? 10 ampere. You got the same value, Hana? So this, from this, one of the question can come in Manipal. Like from this I told you that one of the question will come from the theorem. Either it would be Thevenin theorem, superposition, or maximum power, and one of the question will get it from here. Either it would be source transformation, star delta, mesh, or node. Okay, so now we are studying about the topic of star transformation. So in this, one thing also you need to take in mind, that if two current source are connected in parallel and they are connected in same direction, okay, then in that case we'll add with each other because they are moving in same direction. 5 ampere plus 10 ampere, it will become 15 ampere. Similarly, one current source is subtracted, like they are in the opposite direction. Like suppose again this is 5 ampere and this is 15 ampere. So we'll take the sign according to the bigger direction, bigger value of current, that is 15 ampere. As they are both in the opposite direction, so in this case current will, tell me, subtract with each other, right? So it would be 10 ampere. Similarly, if we'll see the voltage, like if suppose voltage is there and these two batteries are connected in series, this is of 5 volt, maybe this is of 10 volt. Series means positive, negative, then in that case what happened? The battery value will add with each other. That is how much? 15 volt, right? And suppose we'll have opposite battery, opposite in the sense maybe negative is connected with the negative only and positive like that. Okay, suppose this is 5 volt, this is 10 volt, positive negative negative positive. So in this case again battery are opposite, that means they will subtract with each other, right? If they will subtract with each other, that would be 10 minus 5, it will become 5 volt. Got it? Now one of the question that comes in your Manipal symbol is according to the bigger value of the battery. Okay, this question is from your paper only. I'll teach you all the question from your paper only. Okay, this is suppose 5 ampere, this is suppose 10 ampere, and it is connected with the resistance. Draw the diagram. This is 10 ampere, this is 4 ohm, this is 25 volt, this is 3 ohm, this is 3 ohm, this is 6 volt, this is 2 ohm, and this is 5 ampere. Okay, so in this case you have to apply source transformation. They have mentioned that you have to apply source transformation and you need to obtain a voltage source, single voltage source with a single resistance. Basically you need to simplify it. Okay, yeah, if they mention that you have to use source transformation only, then means source transformation only. You can't apply KVL, KCL or node mesh or anything. Okay, you just apply source transformation, or you can use Ohm's law. V is equal to IR. So I'll tell you, give you a hint. First you can solve this one, right? Both the currents are in the opposite direction. Then current source is in parallel with the resistance, that would be converted into voltage source with the series resistance, correct? Similarly, this current source is in parallel with resistance, that would be converted voltage with the series resistance, and this one. So now all three batteries are in together. This battery, and after conversion this battery. So we have to see whether the battery is in series or in opposite direction. So we need to add or subtract it accordingly, and the resistance add it, right? Do it up to here first, then I'll tell you further. See, first of all, we'll solve this one. 5 ampere and 10 ampere, they are moving in the opposite direction. That will change into to 5 ampere, and that would be downward. Again, this current source is in parallel with resistance, so we can convert it into the voltage source, right? So the resistance is 4 ohm and the current is moving downward, so battery direction is like this, 5 4 20, right? Again, if we'll change this one, then 5 ampere is in parallel with the resistance, then in that case resistance is there and the battery of 10 volt, because current is moving in particular that direction. You got the same? Now see, now after that, as you can see, positive is connected with positive, right? So that means battery is opposite, correct? So 25 minus 20 is how much? 5 only. And what will be the sign according to it? That would be positive again and negative, correct? Resistance 3 ohm as it is, like I'll add all the resistance. 3 plus 4 plus 2 is how much? That will become 9 ohm, right? Any doubt up to here? Now this 5 volt battery and this, it is connected with negative and the positive. It is like this or not? Now they are at the same, these are connected in series or in parallel? Tell me. After this, if I'll solve this circuit further, this will convert it into the single battery of 15 volt. and resistance will be 9 ohm. Yes, and this one is as it is, we didn't touch this part. So this is a 6-volt battery and the resistance of 3 ohm as it is, right? So now as you can see, we can't solve it further. Battery is in series with resistance. Can we convert it into the current source? Similarly, can we convert this one into the current source? So how much is the resistance value? 9, 3. I is how much? V by R. So it would be 15 by 9. And this is how much? 6 by 3. So that one is 2 ampere. Yes or no? So this would be 5 by 3. Now as you can see, these two currents are in the same direction or in the opposite direction? Same direction. And these 9 and 3, we can combine it into the parallel? Yes or no? So if we'll solve it, then that would be how much? Combined into, that is 11 by 3 and 9 and 3 in parallel, means 9 into 3 divided by 9 plus 3. So it would be 9 by 4. Yes or no? Now this is a single current source with the resistance. Can we convert it into the voltage source? So what would be the value? Tell me. Tell me what would be the value? So after solving it, we'll get 8.25 volt and 2.25 ohm. Further you'll solve it and then you can cross check the answer, right? Now the next question based on this source transformation only, like again it comes in your paper which I told you earlier. Now this would be your homework. Okay, first tell me orally that how will we solve it further, and do this question in your homework. I'll tell you the answer also so that you can cross check it. Correct? Now the same question which I gave you earlier, this is from to April 2019 paper. I'll write it down also. This is from April 2019. Okay, 10, 60, 10, 10, 10, 20, 20, 40 and 10 ohm, and its final answer is, if you will have any doubt then you can obviously ask from me. Your final answer is 20 volt, 6.25 ohm. Now tell me orally how can we do it. Now see, current source is connected in parallel with the resistance, right? Current source is connected in parallel with the resistance. We can convert it into a single voltage source, right? Then after that, after getting resistance, battery, right? Then these 10 and 10 will be 20. Remove it. Resistance, battery, right? And then resistance, resistance and the battery, right? And then resistance. You get a circuit like this, correct? Okay, now after that, if you'll convert this one and this one into the current source, can you convert it? Current source with resistance, current source with resistance. These two and those two are in parallel and these will add up. Okay, so again what you'll do this for this one also. Convert current source, convert it into current source and resistance. Okay, then 20 ohm resistance is there. Yeah, so two resistance will become parallel and the current source, then further you can convert it into the voltage source. Okay, then after converting it, then again you need to convert it into voltage, so then you can do it further. Now you will not face, if you uh, so in this case they have to, you have to find current in 8 ohm, so you can't touch 8 ohm, rest all would be changed. Okay, 8 ohm would be similar, rest all of the circuit would be converted. Got it? Now after that, like we have heard, so our next topic is delta transformation. One thing that either they'll give you based on source transformation or based on delta star. Both kind will never come, but it's up to them only that what they will, right? Have to study all this. Next is star delta transformation. Do you know what is basically a star delta? This you will study in detail also in your module 3 also. Yeah, star delta topology. Basically, we'll have two types of supply. Okay, one is the single phase supply and another one is the three phase supply. Single phase supply means we'll have a single wire, and three phase supply will have three wire. Okay, three wire means we'll have three wires which you need to connect with each other. One wire is of red color, another wire is of yellow color, and another wire is of blue color. That is known as by abbreviation RYB. Okay, clear? So now we need to connect it. How we can connect it? Suppose this is red color and we'll have yellow color and we'll have blue color. All these three wires are interconnected with each other and it looks like a star, so that's why it is known as star connection. Okay, now one of the wire again is red color, another is yellow, and another is blue. This is also the one kind we can connect it with each other and it looks like a delta. It is also known as delta connection. Okay, now we can convert from star to delta and delta to star. Let's see how. You have to remember the formulas for that. Okay, let us consider this one is A, B, and this one is RA, this one is RB, this one is RC. Okay, this one is R1, this one is R2, and this one is R3. First of all, you need to study about delta to star transformation. If you are converting from delta to star, tell me which terms you want in the answer, R1, R2, R3 or RA, RB, RC? Means RA, RB, RC, correct. Now as you can see that RA is connected with R1 and R2, right? So its formula is R1 into R2 divided by R1 plus R2 plus R3. Got it? Similarly, RB is connected with R3 and R2. So it would be R3 into R2 divided by R1 plus R2 plus R3. Correct? Now RC is connected with R1 and R3. So it would be R1 into R3 divided by R1 plus R2 plus R3. Yes? Okay. Now we need to convert it from star to delta. Now for this, what we want? RA, RB, RC or R1, R2, R3? R1, R2, R3. Now as you can see that R1 is connected from RA and RC. Yes or no? RA and RC. So it would be RA plus RC plus RA into RC divided by the rest of the term RB. Now similarly you tell me for R2 and R3. Can you? Now do one thing in your notebook, make one formula page, okay, and that will be your last page of your notebook. Write down the heading formula and write down the heading that is unit 1 DC circuit. Okay, unit 1 DC circuit, and then write down star delta transformation formula. Got it? So that it will be your all the formulas will be on the same page. This is the question. Here we need to calculate resistance across A and B. We'll always start with the opposite, like here. Okay, now just imagine you are you are current and you are moving from A. Okay, now this they are, as you can see that these two are connected in the same path, so that means they are connected in series. Yes or no? So if we can't, if we can apply simple series parallel, so it's better to use first that. If we can't apply series parallel, then only we'll switch to star delta. Okay, it's not like that in star delta we can't use star series parallel, we can use it. So it would be 60, right? Now again you can easily see that 60 and 30 they are in parallel, right? 60 and 30 will be in parallel. 60 into 30 by 60 plus 30, 20. So again I am deleting it. It will become a simple 20 ohm, right? Now tell me, any doubt up to here? Okay. Now as you can see that this is delta. Delta or not? Can we convert it into star? So for this value, what we need? This into this divided by sum of all this, means 30 into 30 divided by 30 plus 30 plus 30. Yes or no? 900 divided by 9t. So it would be 10. Correct? So it is 10, it is 10 and it is 10. So basically we have converted delta to star. So I am removing this delta. Okay, understood now? Rest of the terms are same. Correct? Now this is as you can see that this 10 and this 20 they are in series. 30, wait, I'll remove this one. This 10 and no. So again this is delta. Can we convert it into star? This 10, this 10, this 10, right? Again I am removing delta. Why I have taken 10? Because the value is same, 30. Now as you can see that these all three are in series. Yes or no? Now these two 10 are in series. Yes or no? If I'll draw another, then this will be 20. This will be how much? 10 plus 20 plus 10, 40. The circuit looks like this. This 10 as it is, 10 and 10 will become 20. 10, 20, 10 will become 40 and this 10 is here. Now it is a simplified circuit. 20 is connected with parallel with 40 and 10 plus 10 plus 20 parallel 40. So this would be your final answer of RA. Correct? Okay. Understood? Now again another question that comes in Manipal. Try to do this question by your own. No, I'm seeing from the PYQs or PDF. I do like if I can see any question, I do remember that whether this question comes in Manipal or not, but I don't remember the exact paper on which year it will come. Yeah, and lots and lots of students stuck in BT and B. Yeah, that is related to digital electronics. In B you will have some theory, but in BT you will have and in the last chapter you will have theory, and that is up to that students get fed up. Currently also many students are studying BT, like first year students. Okay, now try to do it. That is 80. 80. Both are 80. Yeah, that depends also. In this you can't, you can see that 56 and 2 are not in parallel, right? See what kind of resistance is in parallel if they both are connected at the same point. 56, 2 and this 80, they are not connected, so it is not at the same. So ultimately you have to see for star and delta only. This one you didn't ask, ma'am, what is this one? This one is 2 ohm. Above one is 80. You okay, I'll explain it to you. So in this case, as you can see that this one and this one are in star, right? Similarly, this one and this one are in star. So as you can see, the values is also same. If they have given some kind of symmetry, na, then that means that there is some kind of symmetry, then only the values are same. Okay? Convert this star into delta, convert this star into delta, and then redraw the diagram and send it to me. See, this would be how much, like delta. I told you not the point, or you can mark the point, like mark it X, Y, and Z. So delta would also be through same point, right? So this is one of the delta. Yeah. Again, for this point Z, Y, and let us consider G. So it is between Z and Y, Y and G, and Z and G, right? We'll do it. First, we have to do it like this, step by step. Okay, otherwise you'll get confused. So if we'll solve it, then this will be 8, 8 and 16 by 3. Again, this would be 8, 8 and 16 by 3. Now, as you can see that these two are connected in parallel, right? So eliminate it. It will become a single resistance of 4 ohm, right? So this will become a single resistance of 4 ohm. Now we have to see that what we can do it further. This 56 and 8, you can see that these are in parallel. So if we'll solve it, then again that would be eliminated, right? One come resistance, I don't know the value. Now this resistance and this resistance, they are in again parallel. So that will be again combined into single resistance, right? Again, I don't know the value after coming it. So these two resistance are in series now. Then they'll add up into a single one. All this will be, you have to do all this step by step. I am doing in this only, right? So then these two are in parallel. Above one, two are in parallel, right? This one and this one will become a single one. Then these two are in parallel. Then I combined it series. Then these two are in parallel. Okay. Then you can further do it, right? I'll tell you the final answer so that you can cross check it. RAB is equal to 2 ohm. Note it down. R2, right? Always marks the point. Like this is X, this is Y, and this is Z. So yeah, a star is connected between X, Y, Z. So delta also must be connected between X, Y, Z only, like this. And you can use star to delta formula and then you can get the values, right? Now you can see this resistance are in parallel, this one is in parallel, this one is in parallel, right? So if I'll redraw the circuit, then it like this or not. So now as you can see that these two resistance are in series, that would be combined in parallel with this one and then further solve it parallel. This is how you can get your RAB. Yes or no? It's easy or difficult? It's easy now, but you just need to know about the concept only, right? And I'll tell you the value also. RAB final value, you will get it as 0.94 ohm. You can cross check your answer. Okay. Now